Alright guys, good evening. Today we're going to talk about 5-2, prove and apply properties of perpendicular bisectors of a triangle, prove and apply properties of angle bisectors of a triangle. When there are three or more lines that intersect at one point, it is said to be concurrent. The point of concurrency is the point where those three lines intersect. In the construction that you're getting ready to see, you will see that three perpendicular bisectors of a triangle are concurrent. This point of concurrency is the circumcenter of the triangle. The circumcenter can be inside the triangle, outside the triangle, or on the right triangle. Okay, so let's look at this acute triangle right here. You've got three perpendicular lines here. This line here is perpendicular to this segment. This line here, perpendicular to this segment. This line here, perpendicular to this segment. They intersect right here at this point of concurrency. This is called the circumcenter. On an acute triangle, the circumcenter is inside the triangle. On an obtuse triangle, the circumcenter is on the outside. And on a right triangle, the circumcenter is on the hypotenuse. In fact, it bisects this hypotenuse, this segment here. All right, your circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of the triangle. So what we have here, this must be an acute triangle because our circumcenter is inside the triangle. And we have a perpendicular P. Well, this segment right here is perpendicular to segment AB. Therefore, PA to the vertice is congruent to PB and to PC. Because your three perpendicular bisectors here intersect right here at the circumcenter. Therefore, you know that these segments that go to the vertices are equal. The circumcenter of triangle ABC is the center of its circumscribed circle. A circle that contains all the vertices of a polygon is circumscribed about the polygon. Okay, so guys, what this is saying is we have triangle ABC. We have the circle. P is the center of the circle. The circle is circumscribed around the triangle. It's on the outside of it. Okay, so let's apply this. Okay, D, G, E, G, and F, G are perpendicular bisectors. Okay, so perpendicular bisector, perpendicular bisector, perpendicular bisector. Find GC. Find GC. So we're looking for this segment right here. Well, we know that G is the circumcenter. Of triangle ABC. Therefore, G is equidistant to the vertices. So, GA, no measurement. GB is 13.4. So we can say GB is equal to GC. GB is 13.4, so GC is 13.4. All right, use the diagram to find GM, GK, and JZ. All right, we need to give more information here. Don't have enough information yet. So let's say that this is also given. MZ is perpendicular bisector. Of triangle GHJ. Let's say that KZ and what is that? LZ. So once we know that these three segments are the perpendicular bisector of the triangle, we can say that Z is the circumcenter. And once we know that, let's see, GK, let's look at GK here. GK is going to be equal to HK. GK is going to be equal to HK because this bisector bisects this segment. Okay, so if HK is 18.6, GK has to be 18.6. All right, and then we need GM. GM is this right here. GM, well, MZ bisects GJ, so if JM is 14.5, that has to be equal to GM. So GM is 14.5. And then JZ, JZ, well, that's from your circumcenter to your vertex, so that has to be equal to GZ. And GZ is 19.9, therefore JZ is 19.9. Okay, find the circumcenter of triangle HJK with these vertices. All right, so let's go ahead and graph it. Once you graph it, you realize there's H, J, and K. You realize that triangle HKJ is a right triangle. How do we know that? We've got a vertical and a horizontal line, therefore that is a right angle. Okay. You know that the circumcenter of a right triangle is on the hypotenuse, and it bisects that hypotenuse. So what we need to start thinking is midpoint of the hypotenuse. Okay, so that's going to be midpoint of KJ. Well, K is 0.6 and J is 10.0, so let's do midpoint formula here. So we've got 10 plus 0 over 2, and we've got 6 plus 0 over 2. When you simplify that, you get 5 over 3. And this is your circumcenter. Let's check it. Right 5, up 3, it's going to be about right there. Okay, I'm going to be quiet, let you do this one on your own. And there's your circumcenter. Okay, that's it for part 1.